Welcome to another tutorial of the thermal system design class. So today we're gonna continue on the problem that we are solving, which is a laminar flow over a heated cylinder. We already have our geometry and our mesh, so we're gonna click on our setup. So it's gonna ask us, we have a 3D problem. We're gonna select double precision. We're gonna click on start. Now that we started, we can see our geometry, and we can see our inlet flow and our outflow. We can also see that the body is in the symmetry. It's selected on yellow. You can see inside of the domain as well. We have the cylinder. We're gonna go to general first. The type of solver we're gonna use pressure base, and we have steady. We're gonna go to models. We're gonna turn on energy equation, and on viscous we're gonna select laminar. We go to material. We go there. Here we have some constants for the air. Make sure that these constants are the same that you're using to calculate anything else. You'll see that right now we'll have to calculate the velocity, the initial velocity. We saw cell definition, solid. We go to boundary conditions. If we click on the inlet, we click on edit. It's gonna ask us the magnitude of the velocity on the inlet. To do that, we'll take the boundary conditions. So we know that our inlet velocity is based on our Reynolds number, which is 100. And this is the Reynolds equation. We'll use the viscosity, the density, and the diameter in order to solve it. And we have the Reynolds equation right here. We isolate for velocity, and we obtain these values, 0.028 meters per second. Again, make sure that these values are the same as the ones that you're running on ANSYS, or if not, your results are not going to be accurate. So this is going to be 0.028. Our gauge pressure is going to be 0. We click apply. We apply it. We close. Our cylinder wall. Click on edit. As we can see right here, our cylinder temperature is going to be 80 degrees Celsius. So we will go to thermal. We'll define temperature. It's on kelvins, so it's 353. If you have the heat flux, you can use this number. You can also use convection as well as radiation, or a mix of different conditions. So it's definitely depending on your problem is what you will be getting right here. So we'll select temperature. Momentum, we have a stationary wall, so it doesn't matter. So we apply it. I'm gonna go back into inlet because our inlet air temperature is gonna be 25 degrees Celsius, so it's gonna be 298. Apply it. Our interior, our outlet. Remember that from last time, we're gonna define this as outflow. The flow rate weight is gonna be just 1. We apply it. Symmetry wall is just a wall. So we have defined our boundary conditions. If we click on reference values, we'll see the different values that they're included in this problem. Mesh interfaces, we don't have any mesh interface nor a dynamic mesh. Click here into zone. Then on our solutions, we're gonna go into our solution methods. So we're gonna select simple. We'll have a least square cell base, a second order. Both momentum and energy, they're gonna be a second order upwind. Go to controls, we're gonna leave this as default. We go to monitors, we're gonna click on our residuals, and we're gonna increment our convergence criteria. We click on OK. We go to initialization. We're gonna have on hybrid. We initialize. Notice that here on the text console it's providing the numbers. Then we click on run calculations. We'll run this for 300 iterations at first. Remember to check just to see if anything is good. Here's recommending me to check my meshing. Let's run it as it is and see which results we'll be getting. So depending on your computer is how much time is gonna take you to run these simulations. The more complicated the problems are, the longer the computer timing would be. So we'll wait for this to finish. So now that the residuals have finished and the iterations have finished, we'll continue our next tutorial looking at the results.